Assalamualaikum and a very good evening. Okay, so today I would like to present our project on the hydroponic system, indoor hydroponic system using Labview. Okay, so as you can see here right now we have the block diagram. So we have two while loops here. So basically this while loop consists of each while loop consists of each sensor, which is LDR sensor and soil humidity sensor. So this first while loop here, which is responsible for the soil humidity sensor, and the second while loop here is responsible for the LDR sensor. So okay, so brief explanation here is we use like comparator method in order to provide sufficient output for the actuator, such as for the LED matrix display and the relay module. So okay, so that's just a brief explanation on the block diagram. Okay, so for the front panel here, right here, okay, as you can see here, is currently operating and is currently connected to the Arduino Uno, which is taking real-time data, such as for the soil humidity sensor we have right here at the bottom left corner, which is the soil humidity waveform chart. We can see here is we cannot read the what the readings here, but we can actually read the exact reading here, which is right here. So this is for the soil humidity sensor, and this right here is for the LDR sensor, and this right here is for the LDR sensor waveform chart. So basically we are currently using Podcom ASRL31, but duly noted that this Podcom is actually can be changed in multiple times. Sometimes it can be changed because when connecting and disconnecting the what we call microcontroller of the Arduino Uno from the computer, the Podcom can accidentally change, like increasing in numbers. So currently now it's 31, so maybe if we disconnect and connect it back, so it will change to ASRL32. So that is from our observation. So right now it is running at with a 10 millisecond delay, which is a very fast response to receive analog readings from those two sensors. And so that's all for the Labview program, and the Arduino is just, I don't want to go into details, but just a brief showcase of how the whole coding is represented right here. So we use LED matrix, which is 8 by 32 LED matrix, RGB actually, and this is the pin assigned to the microcontroller Arduino Uno, which is pin 8. Okay, so this right here is the LDR pin outs A1 analog 1, and this is the soil humidity assigned with the A2 analog pin outs, and relay is assigned with digital pin 6. And this here is just a brief showcase of how the void setup is being set and the void loop. So this, okay, so noted right here we have serial data. So this serial data here is responsible receiving information or data from the Labview. So the Labview is actually provide like serial data, string data. So the string data can be interfaced with the Arduino microcontroller, which is received by this program. So this program right here, if the Labview is printed H string data, okay, it will activate this kind of action. So here action is to turn the LED matrix to a brightness with 100% brightness. So hands down, that is for the showcase of the Labview and the Arduino coding program. Let's move on to the experimental setup and how it's simulated. So
hello.
So this is the concept design of the hydroponic system. So as you can see, this is the experimental setup. So we got here is the Arduino Uno as the microcontroller, which is the processing for the processing, and we have the soil humidity sensor, we have the relay, we have the external power supply to supply the DC motor valve, and we got here is the LED matrix display. We are using the red and blue color spectrum, which is effects in hydroponic in providing an efficient photosynthesis. And also we got here is the LDR module to LDR module sensor to detect light intensity of this whole room. So I don't want to show the whole room because it's kind of messy. So anyway, back to the experimental setup. So here we have the plantation itself. So we have the water tank, and the water tank is filled with water, and the hose here will provide the water to the plantation, which is pump using the DC motor water pump. And the hose here is for the is actually like a safety measure in case of the water is overflowing out of the plantation. So and I don't want to wet the whole table by the water of the plantation. So this hose here right here will send the extra water to prevent leakage. It will send the overflowing water back to the tank, which is kind of like a closed loop kind of system lah. So now here we have the Labview front panel. So here we can see this right here is the soil humidity waveform chart. This is the LDR chart. So as you can see, both here are actually measuring, recording the readings of the both sensor. So this is the soil humidity sensor, so this is the LDR sensor. So we are using the Podcom. So but noted here is if we are sometimes we need to refresh the Podcom in case the readings are measured incorrectly or illogical. So we must check this com kind of like multiple times, and then we go ahead with the experiment. So we're using byte count 256 for the both sensor. So as you can see right here is actually the readings for both sensor. So this is for the soil humidity and LDR. So this is both a buffer and this is the reading. So as you can see right here, there we have the waveform charts for both sensors. So right now I want to demonstrate. So we don't have any plants, we don't have any flowers or strawberries. So I'm just gonna like simulate the real deal. So you can see the plantation is filled with like a bit of water. So I want to simulate what if the water is not like filled enough in the plantation. So in order to demonstrate, I don't have the plant or the flowers, so this is just to demonstrate in case of the for the hydroponic system. So when we have plants, so of course in photosynthesis the soil or the plants is using for photosynthesis. So basically like water and sunlight, right? So it's indoors. So this is the main water supply from the tank. So here to demonstrate what if the water is not enough to supply in the plantation. So I'm gonna like demonstrate. So as you can see, the relay will turn on and the water will flow into the plantation, provided by the DC motor water pump. So if it's at a certain level, so as you can see here, it will stop right immediately and the relay will turn off. Okay, so let me demonstrate again. What if the okay, so this is the actual reading in real time actually. So when the water is not enough, okay, so the readings were actually like 900 and above. So this will trigger the relay. So if it's enough, fill enough water, then the readings will go like 300 to 400 measurement. Then the relay will trigger off and the water pump stop pumping water into the plantation. So that's one of the main elements in photosynthesis, which is the water. So what about the sunlight? So we are using concept of indoor hydroponic system, right? So sorry. Okay, so here we have the LDR. LDR is mainly like providing the artificial sunlight in the indoor hydroponic system. So we don't use sunlight at all. It's just depending on. So for photosynthesis, we are using this light, which is the LED matrix display, to provide artificial sunlight. So we are using blue and red spectrum. So there is the LDR right there. So if in case of the okay, so right now the room is actually a bit dim, so the brightness is right now is set to 100%. So what if the room is set to be brighter? So this is a bit difference there. I can't be sure if the camera can see this, but oh my god. Sorry. But the light is a bit like down to 50% brightness. Yeah. But if if the room is lit up a bit more, then the whole LED matrix will turn off. And the brightness is set here to 0. So if there is some light in the room, it will set to 50 brightness, and if there is no or even dim light, will set the brightness up to 100% brightness. Okay, so I think that is all for the experimental. So okay, I forgot to demonstrate about the I forgot to demo on the readings. So as you can see here right now is the real-time readings for the LDR right now. So this is actually at the light intensity of the room right now, the current light intensity. So as you can see here, the LDR is set to be like 500 to 490 something readings. So at this current rate, the LED matrix is set to be 100% brightness. So if there is some light, okay, if you can see the readings start to go down a little bit. So if there is more light, it's go down, and then the whole LED matrix will turn off. Okay, etc. Okay, I think that's all from me. Thank you so much, and thank you, Faris, for helping me on this project also. So thank you, sir.